Hey, it's Eamon with ipXchange, and as you can see, we have another in-house visit, this time with John Edwards from poLight. So they're a little bit different to what we usually talk about, but it's very exciting, and as you can see, there's already a few end products that this technology has found its way into. So John, I think the best thing to do is start with what do you do at poLight, and then just give a minute about what poLight's all about as a company.
Yeah, so my name's John Edwards. I'm VP Business Development at poLight. Basically, that's a classic biz dev role, so a combination of sales and partnerships. So there's three of us that are involved in business development at poLight. There's myself covering Europe, Middle East and Africa, and also Japan and Korea. We've got somebody in the West Coast US covering the big major US customers. And we've got a big team in China and Taiwan as well, with business development partnerships out there. So we make tunable optics. So optics are everywhere. What's unique about our implementation of tunable optics is there's a technology platform which is based on piezo actuation.
So this is where it's relevant to you guys, because this is electronically tunable optics.
Absolutely, yes, exactly. So these are electro-tunable optics. So the muscle, if you think of it, the analogy of the human eye, there's a muscle that moves it. In our case, that's piezo actuation. And then the thing that is being actuated upon is our optical polymer and optical membranes. So we have a technology platform that's piezo of various implementations, either thin film or bulk piezo. The optical membrane itself, which is the thing the piezo directly actuates upon, and then the optical polymer, which is some of our core IP, which forms the core of the lens. And through that technology platform, we can make optics which can be electro-tunable, either focus tunable for our T-lens, or we're developing products that will be beam steering as well, where you're shifting the angle of a beam. Cool.
So I think a lot of you are going to be electronics engineers. That's the core of the ipXchange membership. So I think let's approach this from the application point of view, because you guys are probably thinking about cameras more than you're thinking about lenses, but obviously a lens is a very important part of getting good images. So if we start with where this ends up, where it ends in a system, can you just explain to our engineers where they will see T-lens used when they're building something that uses a camera? And then maybe we can talk about some of the
Absolutely.
bits that are here.
Yes, exactly. So I mean, our product is a lens element. So T-lens is a singlet lens element that's going to be built into an optical system. So these that you see here are examples of the T-lens itself. That's available either as a bare die product, so analogous to a silicon chip, or we can put it in a package to make it easier for customers to handle if they don't want to deal with wire bonding and some of the challenges of dealing with the die. That's built into optical systems by our customers. So our customers take that, they put other lenses around it, and make an optical system. Now that might be, as you mentioned, a camera lens. It could also be optics for lasers, for example, projection optics, or various other things. Optics encompasses lots of different applications. Then that is built into, if we continue with the camera example, that's built into a camera module. Now that might be built by the same people that built the lens, it might be built by somebody else. There's lots of different strata in the ecosystem. And that camera module is designed to customer specific specifications. It might be for industrial applications, it might be for high volume consumer applications, and then that itself is built into an end product.
Cool. So if I was to summarize that, then poLight are providing the optics part of your electronic system. That's correct.
Yes.
Rather than the image sensor itself. But
exactly.
Obviously, when you use it with an image sensor, you can get some great benefits.
Yes, indeed. So our business model is a manufacturing business model, so we're fabless but manufacturer. So we sell the T-lens, and that's the business relationship. But in order to do that, we have capability to support with optics design, with mechanical design, and with the system level design of implementing tunable optics in systems as well.
Nice. So probably a good direction to go in would be, obviously people are already using cameras and they're already using optics. What's the key benefit of T-lens and poLight's offerings when compared to what people are having to use at the moment, and what are some of the examples of the technology that people are having to use at the moment to perform the same function?
Yes, so in a lot of instances people are just using fixed lenses, so fixed focus, so they're not changing focus at all, and for many applications that's sufficient. So some barcode reading applications, there's just fixed focus. Many camera applications are just fixed focus. Now, customers quite often want to be able to change focus, either to accommodate different depths of field, different distances to the object, or they might want to change focus to compensate for things that are varying in the system. So even if they intend to keep a fixed focal distance, due to thermal variations or assembly tolerances, they might need to change the lens, to tune the lens to accommodate that. But most often, customers come to us because they want to change the object distance, they want to focus on different objects.
Cool, and so what are they using? If they weren't using T-lens, what would they be using at the moment?
So the dominant one in the industry is something called VCM, so that's an actuation system. VCM stands for voice coil motor.
Oh yeah.
So basically it means magnets and coils of copper. So you have a fixed magnet and a variable magnet through your coil of copper, and by changing the current through that copper and acting against a spring, you move things. So it's called voice coil motor because typically that's how speakers and microphones work, but actually in the camera industry you're using that actuation to move a lens, and there you would be taking that fixed lens that is providing your fixed focus and moving the entire system in relation to the image sensor. So you're familiar with your with cameras where the lens may move closer or further from the image sensor. Typically that's how most focusing is done in camera systems. So for a long time that was the only technology in smartphone and the only technology in many of these industries. There are other systems that move an entire lens system, so SMA is another example of a system where you can move the entire lens objective back and forward. And then there are also other tunable lens technologies. So there are lens technologies based on liquids. There are two dominant technologies based on liquids. There's electrowetting and pressure controlled liquids. And each one of those has particular sets of strengths and advantages. Where we tend to be successful is where customers care about power consumption, speed,
I was about
size.
to say that this, because it's piezo-actuator, I'm sure it's much less power consumption than having to do voice coil motors.
Yes, absolutely. So I mean, typically we're talking about power consumption measured in milliwatts. Nice. So I mean, it could be even at continuous operation a milliwatt consumed in the T-lens, and that's 2 orders of magnitude less than a VCM operating against a spring. So that's an instance where if customers really care about power consumption, and many of these devices like the AR head-mounted devices, they do care about power consumption, then we compete very strongly in that space.
Cool, and just out of interest, I mean, these look really, really small. Is there also a size benefit as well, or?
Absolutely, there is, yes. So because the system it incorporates both the actuation and the lens itself, there's no external actuation. So compared to the VCM, you have wrapped around the lens, you have this motor to move it. We don't have any of that, so it's all built into the T-lens. So that means that we can be much, much smaller. So we make some of the smallest cameras. It also means that we can be designed into applications where size really matters, such as endoscopy. We have applications in healthcare where low mass and small size are really important because the camera is mounted on a rodent that's actually performing challenges. So any excess mass or size is going to restrict the decisions that the rodent makes, and it means that the research isn't as valid into the decisions that the rodent's actually making.
Cool. So one more technical question, and I think we should explore these actual real-world products in a bit more detail. So one more technical question. Obviously, optics is a wide spectrum. What does T-lens cover at the moment?
You mean in terms of wavelength?
Yes.
So I mean, most applications that we end up in are targeted at visible light. So that's the sort of 400 to 800 sort of band. The T-lens itself transmits in excess of that into the near infrared range. So we have coatings on the T-lens. We have an anti-reflective coating, which is there to prevent reflection, increase transmission, and that has a spectral characteristic. So for the visible light applications, RGB applications, that starts to roll off around about the 800 range.
Okay.
We can also tune and tweak that coating to extend it into the near infrared range. We characterise the devices themselves up to 1050 nanometers, but that's because our measurement system uses silicon photodetector and stops at 1050. Yeah. At that point, it's still transmitting. So we're confident these transmit well into the near infrared range, and many of the applications that we use do actually require transmission in infrared range. So there's some automotive applications and other applications.
Sure. So a very wide range of applications served because of that wide range.
Yes, absolutely. Yeah. I mean, the core technology. So before we put the anti-reflecting coating on it, I mean, it's a very wideband technology. And then that's constrained by the anti-reflection coating that we put on for visible ranges, because most visible cameras will have an IR cut filter in there anyway for colour purity. So yeah, the technology itself is very broadband.
Nice. So as you can see, there are quite a few end products here, which means the T-lens is an available technology.
Absolutely. Yes.
So yeah, quickly, John, can you explain how the T-lens is working in each of these devices that we have here?
Okay, so here we have a selection from the different markets that we serve. So if I take from the front here, so this is what's called a scan engine from Honeywell. So Honeywell take the T-lens, build it into this optical system, which they then sell to end customers. So this scan engine here goes into barcode reading devices. You can see that the same device is built into this handheld device here, which is a handheld barcode scanner. This is the sort of device that ends up in warehouses and things like that, where people want to image barcodes that may be close to them or far away.
So I guess the key benefit of the T-lens in that is you can adjust the range.
Exactly, yes. Yeah. So the typical person in the warehouse might have a box that's right next to them. They might have one that's high up on racking, and they want to be able to capture those barcodes at speed with ease. Cool. Then there's other industrial applications. These are machine vision type applications from a variety of different customers that we work with, where the T-lens is again compensating for different object distances, and the speed is extremely important in those applications. Speed and stability, because they want to be able to very quickly image devices that might be either of different physical sizes or at different object distances.
Nice.
Moving on to some of the more consumer applications, we've got a smartwatch here. This is a smartwatch for particularly targeted at the child market, where the T-lens is providing just a classic camera function. So they've got a camera in there. They want to be able to take pictures of themselves or of their friends with the background in focus, but they might also want to scan QR codes or take pictures of something quite close up. So that's just a classic camera focusing application. Similarly with the smartphone, here we're in the front camera of this smartphone here. So again, you want to be able to take pictures with the background in focus or focus on yourself. So the T-lens is providing the focusing function on that front-facing camera there. And speed and power consumption are extremely important in smartphone applications. Then coming on to, this is just an example of some of the many devices that we're in XR, AR and mixed reality devices. In this one here, this is from a company called Vuzix. This camera here is using T-lens to image the environment around about the user. That's a very hot market just now. Lots of devices in augmented reality and mixed reality. Many of these devices have several cameras on them, either for just classic image taking, for informing an AI. So there might be an AI there that's helping you interpret or assisting you about the environment round about you. So those devices need to be able to, you can imagine it would be maybe reading a menu close up or taking information from the environment you're in. In these types of devices, they're, as you can see, that getting the form factor small is important. Now that means that there's two challenges. First of all, you don't have a lot of space for a battery, so power consumption is really important. Secondly, you don't have a lot of space to dissipate heat, and you've got surfaces that are close to you. So you need low power consumption also, because any milliwatt you dissipate in power turns into heat that's then really challenging to get rid of.
Cool. I've also noticed, is that a camera on both sides? So that's
it is, yes.
Stereo optics.
In that particular one, there is, yes. So we have other applications in something called video see-through, which is where it's a different form factor, so you have the more classic VR type form factor, so it's a closed system with a display in front of your face, but then your view of the surrounding environment is passed through, so there's a camera that captures and passes through to you. Now, if you do that with fixed focus, then it's a very unnatural environment, because your brain's constantly using your eyes to focus. So you need focus in that application, and again, they have one camera placed coaxial with each of your eye, because your brain's very sensitive to things that look different to how your brain interprets the world. So good, high quality autofocus in those is really important.
Cool. Very, very interesting. And it's on a very slight tangent. That brings up another very interesting thing, because we talked to another company about spatial audio and how your brain really, really doesn't like hearing a voice coming from the center of your head.
Yes.
And I guess this solves that cognitive dissonance as well.
It does, yes. So your brain's really, really sensitive to things that are close but not quite. There's that uncanny valley effect. Your brain's really willing to tolerate something that looks very different from reality, and it'll just accept that. But the closer you get to looking like reality, the more discomforting it becomes. So placement of cameras is really important, performance of cameras, things like speed of reaction time, all of that plays into giving an experience which isn't discomforting to the brain. Doesn't, and in worst case, in AR devices, in VR devices, it can have truly discomforting. Motion sickness, lots of nausea, all those sorts of things. Both when you go into the device and when you come out of it as well. So giving designers more flexibility in the performance they can achieve from the cameras and how they can place them is extremely important.
Nice. So I guess, as we always want to come on to, how do you evaluate this technology?
Yeah, exactly. So evaluation is really important to us, getting the technology into engineers' hands, allowing them to play with it. So we have our evaluation kit that we manufacture at poLight. So that is basically a USB device that allows an interface to our driver IC. There's a GUI that comes with that and allows you to play with the bare T-lens itself. And use that in your evaluation system, whether that's a vision system or laser-based system.
Cool.
That's available from us. We also have the T-lens packaged up by Thor Labs. They've been a great partner with us, and they have their own evaluation environment that's available through them. And that's a really easy way to access the technology. And we can supply cameras and camera evaluation systems as well. All of these are ways which we allow the engineers to play with the technology, and those all partner with the optics modelling and simulation expertise that we have. So what's important is being able to both simulate the system, predict how it should work, and measure actual systems and take that data and see what it's actually doing, and then measure any similarities or differences between the two.
Cool. And just to double check, so does poLight make the T-lens and the driver chip?
Yes, we do. Yes, exactly. So we're fabless for both of those. The polymer is the only bit we make ourselves. Everything else we're fabless for. The drivers we sell. It's just in a standard fabless model. I mean, it's a 3x2 micro CSP. It's pretty unexciting.
So also saving space.
Yes.
Cool. So this is a question that we always like to ask at some point. We haven't asked it yet. If someone was to approach you with an interest in T-lens or just poLight in general, what does your ideal customer look like? What quantities are we talking about?
Well, we can be very flexible on quantity. So, I mean, we have an established supply chain. We've got great partners. We've got a very good operations department. So I mean, some of the applications that we sell, so the Mini 2P, the medical application that I mentioned, I mean that's sold in low tens of units to individual customers, right through to high volume smartphone. What's important to us is customers that really get benefit from the features of the technology. So customers that are going to really value the features we can provide, either the low power consumption, the small size, constant field of view during focusing, all these things that the T-lens are quite unique providing.
Cool, and I think that was a perfect summary of everything that was said. So thank you very, very much, John, for coming in and showing us all this cool tech. Obviously, if you're interested in evaluating T-lens for a commercial or industrial or even an automotive application, check out ipXchange.tech, and yeah, it'd be very exciting to see where this goes.
Hey, yo, where my engineers at?